My channel, and today I'm going to be talking about independent set problem P on the AtCoder DP contest. So we have a tree with n vertices, and this is just the way to represent the tree. It's just like the connections of the tree, and you can either paint a vertex with black or white, and two adjacent vertices cannot be painted in black. That's your only constraint. Okay, so let's look at this. When you have, just simple, right? 3 in a line like this, then let's say it's blue as black, right? So if I put 1 as black, then this has to be white, and this can be white or black, right? If this is white, then this guy can be black or white. If it's black, then 3 has to be white. If it's white, this can be white or black. So that is 5 ways. That's the correct amount of ways, right? So 2, 1, 2, right? 5 ways. Okay, so how do we use DP on this? Well, it's a tree problem, so immediately we can start reusing some information, right? Because it's a tree, it's hierarchical, right? So what the parents answer, right, for each subtree depends, right, on the children of the root node, right? So if we look at this here, let me just lay it top to down just so we can look at it like a tree. How many ways is there to color this subtree, right? There's 2 different ways. How many ways is there to color this subtree? If it's white, you can check how many ways is there to color 3's subtree given that 2 is white. Or if it's black, you want to see how many ways subtree of 3 can be colored given that 3 basically can't be black. So those are your only 2 things, right? So what my DP would be is for the subtree of vertex I, for that subtree, given if I is black, right, or if it's white, right, so it's 2, if it's black or if it's white, how many different ways, how many different combos of the color, okay? And because it's a tree, we can just use the children to calculate this, right? So since no 2 nodes can be adjacent, if we're looking at some subtree, right, let's say we have something here, right, there's a few down here, the DP, in this case the DP of 1 of 0, let's say 0 is white, whatever white. For white is equal to, essentially what you would do is you would multiply, let's see, this is 2, 3, and 4. You just multiply the DP of 1, or sorry, you multiply the DP of 2 of white, and you would add here DP of 2 black, right? And you would do this for every single child, right? Because in this case, well, this would look better, right? White. Because node 1 is not black, then any of their children can be black, right? So you would just multiply all of these, right? But if it's black, then none of the children can be black, right? They have to be white. So you have to say, what is the number of ways to color the subtree of 2, given that 2 has to be white, right? And then it would just be all the way down, right? It would just be 3 and 4, and you would just multiply all of these together, right? Just write it out. Now you would multiply all of these together, and that would be your answer for black. Now, if we calculate all of those in this similar manner, then we can reach our solution in n times 2, right? So we would need to calculate, and then it would be like times it would just be that, right? Because you would just do DFS, and then you would do 2 of those DFSs, right? Once where you're calculating all of it for when it's white, and you would also need to calculate it for when it's black, right? And because n is less than or equal to 10 to the 5, this will pass. So how would it look like, right? You'd have a DFS. Here you'd have DFS, and you'd have the vertice, right, int v. And what you would do, you would initialize dp of v of white. Let's say white is 0 and black is 1, and dp of v of 1 to be 1, right? And then what you would do, you do for c of v, right? So that's just like the child for all children of v. dp of v 0 times equal dp of c, right? So if v, the parent, is white, then c can either be white or black, right? So we would add these two. Both of them count as possible colorings, but in the case that v is black, c must be white, right? So then we just multiply c of 0. And that's your entire pseudocode. By using the fact that, we have a tree, it's hierarchical, there's no like cycles or anything, we can just calculate the number of ways of coloring each subtree, given that it's white or black, and using the children, we can calculate the dp of the parent in a very fast time, right? So, and this would be O of n. So I hope this helped. This is a good example, good like first introduction to a tree dp, and thank you for watching. I'll see you next time. Bye.